morning.
Good morning.
Give us an idea of the situation regarding food waste in the UK at the moment.
Okay, so there's an estimated 16 million tonnes of food waste in the UK every year. And a big proportion of this will come from industry, manufacturing and processing. Some of this, of course, is unavoidable, from trimming, from processing waste and residues that come out of the manufacturing process. Historically, this would have gone to a waste storage area at the back of the facility and then ended up in the landfill. Now, there's a massive drive on landfill diversion. So what happens is that the facilities are actually pushed to try and store for longer or treat it themselves. And what they can actually do, what actually happens then is the storage ends up becoming larger storage required until it can then be processed on site or actually transported off site to another destination.
A real key to this, obviously, is if there's a way that we can actually reduce that waste in the first place.
Yes, so dewatering by mechanical separation. GEA, we supply centrifuges where we can take away the water element. So basically, when the waste comes out of the plant, it's coming with the processed water, it's coming with the residues. There's a high liquid content in there. We can separate that through mechanical separation into two separate fractions. So we can take the solid element away from the liquid. The liquid element is then a mixture of oils, greases, and the water. That can then be further treated. It can go on to be utilised into the biodiesel industry if it's further refined. The water element can then be treated on site through very simple means before it is then discharged. We then concentrate up the solid fraction of the food waste. Then that has very good nutrient values in that, which then can go on and be further utilised. And by doing that, you're concentrating it up, you're actually reducing your storage costs, you're making it easier to handle, you're reducing the volumes, which actually then goes on to reduce your transport costs for if it's taken off site.
And actually, you hinted there as well about ways of actually reusing this waste as well. Tell us more about that.
So utilise the nutrient value. You're concentrating the solids up and there's an element of nutrient value in there. Now, there's been a push for landfill diversion, and all these nutrients historically would have gone into the landfill. The landfill sites then produce greenhouse gases, which then are not good for the environment. They then become attractive to the likes of animal feed or the likes of anaerobic digestion. In anaerobic digestion, food feedstocks are very attractive. They've got good nutrient values, they give a good gas yield. What happens there is then the microorganisms are breaking down the food waste solids, creating a methane gas, which then can be used to run an engine, creating electricity, which can go back into the national grid, or it can actually be used on the site in terms of renewable energy source and make them almost self-sufficient. The gas could actually be scrubbed up and actually injected back into the grid as well. What happens with the microorganisms, once they've biodegraded all of the food waste that's been put in there, we actually need to keep the process continuous, and to do that we need to remove some of the wasted product out. Once it's done its job, you've got the maximum amount of gas yield out of it that you possibly can, we then need to take it out and include some fresh waste into the tank. By doing this, we create what we call a digestate, and the digestate comes out, and this creates another liquid form which actually is approximately 90% liquid. This again creates another storage issue, large volumes, and generally this would be spread to the land. Now, with the land banks getting smaller and with the storage volumes and the farmers having to get the liquid onto the land, by using mechanical separation, we can dewater this again. And by further dewatering it, we're taking the solids away from the liquid and we're creating a cake-like substance which can be stacked, it can be reduced in volume, it's much easier to handle, but it's nutrient rich. We're creating a fertiliser. So it's an organic fertiliser that the farms would normally have to go and purchase. It makes no sense in buying them to put on the land when this is readily available. That's come from a waste product all the way back from the factory. And it's reusing it. It's almost putting the food back on the land where it come from originally. So it's all about circular economy. Now, what we do in GEA is produce machinery that's actually developed over the years to make it much more efficient to take as maximum amount of solids from the liquid as possible. And in doing that, we're actually controlling where the nutrients need to go. The nitrogen and phosphorus levels have to be the right amount going on the land for the crop uptake. There's government drivers which are monitoring what nutrients are being put on the land. Now, by separating out and taking out a massive amount of the solids from the liquid. The solids can be utilised, as we said, smaller volumes, much more easier to transport, concentrated nutrient value. That makes it more economical to transport to fields further away where there's a nutrient deficiency.
It's really amazing that technology can be used in this way to really help us to make sure we're making the most of our waste, we're reducing the amount, and we're able to then actually reuse some. So it's been great finding out more. You've given us a lot of clarity for that. So Chris Clarke from GEA, thank you very much indeed.
Thank you very much.